Great. Okay. So we discussed about the course content, right? So what all things are gonna be covered, and so what I've done, we have made changes to the course content. Okay. So if you go ahead and see, we have updated. So even earlier it was as per PCNSE, but what I've done is I've organized it in a way wherein it will be easier for us to proceed as a course, right? Because if you'll see in the PCNSE, it's divided into topics like core concepts and then implementation and all that. So that makes it difficult to follow for studying it, right? So what I've done, I have organized this syllabus into modules. We have a total of 14 modules, right? And then there will be few assessments in between just to, it's a knowledge check, nothing as like pass or fail. This would be more of like, for you to understand where are you standing at, right? So uh, if you're able to understand the concepts or not, or where you would like to put more efforts, okay? Uh, you can go through this course content through the website networkgeek.in, and then you'll be able to click on that PaloAlto courses PaloAlto, and then you'll be able to see the syllabus. Okay. Uh, let's We have discussed about a few things in the last class. In today's class, so we have already covered this part, right? So review of products offered by PaloAlto Networks is already covered. Today, I intend to cover uh, comparison between legacy versus next generation firewall, uh, PAN OS architecture overview and licenses, and form factors, right? What all available models are out there. So this will be just a very brief discussion, right? Because more of like we are doing our labs on VM firewalls, right? So because we are spinning all these firewalls in a lab environment, we do not have a physical firewall. Okay. So all right, let's get started with this part, comparison between legacy versus NGFW. Okay. All right. So those who all might have attended the boot camp, they might be able to recollect that we have covered this in our boot camp as well. Uh, Legacy firewalls versus next generation firewalls. Okay. Now, what are legacy firewalls, right? Guys, please feel free to interrupt me if you guys have any questions at any point in time. Okay. And I'm more than happy to answer your queries. All right. So legacy firewalls, what are legacy firewalls? Legacy firewalls are the firewalls which were present when the internet era was evolving, and it used to have ACLs, right? ACL is your access control list based on layer 4. Okay. So when we say based on layer 4, we were able to control the traffic based on the port numbers, right? So the port numbers, it could be like, for example, you're trying to restrict an SMTP connection that would be for your email. You can go ahead and block a port 25, right? Or if you're trying to restrict an access to maybe web browsing or HTTP, right? You can go ahead and block the port 80. If you'd like to, go ahead and block HTTPS, that is your current, how you are accessing the websites. This is called a secure HTTP, right? HTTP secure. So you can go ahead and block the port 443. So similar ways, it worked only on ports. There were no, other parameters that could help you understand. Now, what was the challenge with this? Why? I mean, so while discussing legacy firewall, I'll give you the contrast with the next generation firewalls as well. So legacy one use port. But what was the biggest challenge? The biggest challenge was application tunneling, or rather, I would say port tunneling. Port tunneling. Okay. Now, what used to happen is, for example, let's say you have just a simpler example of uTorrent, okay, or BitTorrent, whatever torrent client you like, okay. What you are trying to download any, let's say, any file from internet, okay. You're trying to download any file from the internet, and you have a legacy firewall in between the path, okay. You have a legacy firewall standing in between the uTorrent, or your client machine and the internet, and you have restricted maybe 80 and port 43, that is your internet traffic. And that's how you can restrict the web browsing, or secure web access, right? So let's say you might have blocked the traffic, okay. Now, uTorrent, what you can do is, instead of using 80 and 443, you can send the traffic over port 53, right? You can configure that. So port 53, ideally, port 53 would be used for your, DNS, right? So this would be for DNS. Now, obviously, we cannot block DNS. If we block DNS, then everything is blocked, right? Because without DNS resolution, nothing is going to work in your environment. Now, what happened? You didn't using port 53. The legacy firewall, based on the port number, will assume that this is a DNS request, right? And then this will be allowed, right? Because there will be a statement saying port 53 from this uh, zone, or maybe from this subnet to internet, is allowed. Okay. So what happened now? We just saw port tunneling, wherein uTorrent evaded the legacy firewall using a customized port. And that's it, right? You are no longer able to control uTorrent application. There is no restriction on this application. It's able to exchange the data, and it's able to, download whatever file. It could be a malicious file that it is trying to download on the, maybe the client machine, right? So this was the biggest challenge. And when NGFW comes into the picture, NGFW, what it does is, so we do have port-based rules, right? But then we have a far more app ID-based rules. Now, these are app ID-based rules will give you, visibility till layer 7. So you will have visibility till layer 7, right? So now you can see the difference, why it makes a huge impact, why having an NGFW is more preferred than having a legacy. When I say legacy firewall, one of the example would be Cisco ASAs, when they did not have app IDs and all that. It was just writing a statement, or even the router where you define some ACLs, right? That on this port, just restrict the traffic or permit any on this particular port, right? So those things do not have visibility on your layer 7, that is your payload. And that's the reason they'll never be able to identify what application is actually going through it. They just classify the traffic based on the port numbers, right? So this is one of the major improvement, I would say, with NGFW. The second most important thing is state, or statefulness, right? I guess someone asked me in last class that what do you mean by stateful and stateless, right? So now when we say statefulness, we understand that okay, let me throw this question to the forum, you guys out there. Would anyone of you like to answer this question? What do you understand by stateful and stateless? Anyone, guys? Okay. All right. No worries. So let me go ahead and do that for you. Cool. So stateful, it simply means having a state, right? Having a state, that means wherein we have some information already present about the traffic flow. Okay. Now, if I talk about legacy, okay. So you can just see, guys, anyone, if you'd like to say anything or if you'd like to answer, just raise your hand and I'll unmute you. Okay. All right. Cool. So if we talk about legacy, right? In the legacy firewalls, you have to define ACL in the inbound direction as well as, sorry, my direction was wrong. In the inbound direction as well as outbound direction, right? Why am I saying that? For example, you have written a rule where it says allow port 80, okay? And this is like from your maybe LAN subnet to WAN subnet, right? What it will do, your packet, for example, you're having a TCP SYN packet coming in, that will be able to go across. Okay, you will be able to see that the TCP SYN is going through the legacy firewall because of this particular rule. But then, if you see the return traffic, right? The return traffic would be the response from the server. That would be your TCP SYN ACK. That packet is gonna get dropped. Will get dropped. Why? Because there is no specific rule that is allowing this particular flow, right? So this is one flow. This is, we call it as C2S flow, right? So C2S, we have written a specific line or rule that will allow your traffic, and that is the reason your TCP SYN went through. But when you talk about the return traffic that would be coming from your server, that will be your SYN-ACK, and we call it as like S2C flow, there is no specific rule that will allow this flow. And this does not have, this particular rule will have no idea about the return traffic. Okay. So there is no way this rule can take care of the return traffic because the firewall, the legacy firewall, does not store any information related to these flows. Okay. This is called as statelessness. So statelessness or stateless for simplicity, right? We Statelessness simply means that there is no state or there is no information present on the firewall related to C2S or S2C flows. Okay. If you talk about NGFW, it is stateful firewall. What do I mean by stateful firewall? It has some sort of information available so that you don't have to write the same, you don't have to write two separate ACLs over here or two separate security policy to be more specific over here, right? So the same security policy would be able to allow the same flow. Okay. Now what happens is C2S and S2C are combined together to make something called as session, right? So this individually, these are called as flows, right? So C2S flow, S2C flow, when together combined, will create a session. We'll see more of this when we, jump into the GUI and try to get the traffic flowing across your firewalls. We'll be able to see all these things, right? So you don't have to worry if in case something feels like, oh, I'm not able to understand the C2S and S2C or what a session is, right? So as of now, this is just an introduction. I'm not giving any any technicality of it. This is just to understand. One second. Yes, Kishore, you can unmute, I guess. Yeah, Kishore, tell me.
That stateless firewall will not handle the connection table. Stateful firewall will take the connection table. Based on the connection table, it will allow the traffic. Even and also we need to apply the ACL rule. But my question is, nowadays in today market, most of the firewalls are having a next generation firewall. Even Cisco also upgraded as a FTD. Then
Right.
why we are to the PaloAlto?
Okay.
What is the specific reason?
See, now that question would be a bit of a diversion from what we are actually discussing, but let me give you an insight, okay? Now there are now you will see every firewall calls themselves on next generation firewall, be it Sonic Wall, be it Sophos, be it, Cisco FTD, Palo Alto is out there. So these new generation firewalls are there, right? Right now we are just discussing about what legacy back then, how things look like, and now what has changed, right? But now your question is why go for a Palo Alto? Now that would be very specific. That's a very specific question that totally depends on the customer, right? Now, see, Palo Alto is a leader. Palo Alto has various other implementation. It's not just having a session or connection. The session alone is not going to make much of a difference, right? The capability of the firewall in itself is going to make a huge difference, right? How you process the traffic, what is the latency, what is the throughput of your device, what are the how stable is your pan OS? So for example, we have Palo Alto Networks OS, right? That is, we call it as pan OS. How
Oh, yes.
stable is your OS? How stable? So for example, pan OS might have few bugs. Definitely every software has bugs. At the same time, FortiGate will also have their own bugs, right? So how stable is that? If there is a challenge, how soon you can mitigate? How are your services being catered to your customers? So a lot of factors are there. Right now we are just discussing about the comparison of your legacy firewall and next generation firewall. What's the basic difference between them? Okay.
Yeah, okay. Thanks.
All right. Cool. All right. Anyone else? Anything? Shrikant, you said the returning flow server to client S2C will get dropped. Could you let us know why it gets dropped from the server to client? Yeah. So that's what we are discussing, Shrikant, right? In the legacy firewall, there is not, it does not have a specific rule to allow that flow. You have written a rule in this direction, C to S, okay, wherein you will be saying, okay, the traffic from LAN towards WAN. So your server will be sitting over here in the WAN environment. So it will be allowed based on this particular rule. But when the reply that comes back from the server, it will be coming from WAN to LAN, right? Now you see there is no statement return over here that will allow this particular flow, right? We'll not be able to allow WAN to LAN because there is no specific, ACL written over here that allow this flow as well, right? So this is why the return traffic will get dropped in case of a legacy firewall. But if you talk about next generation firewall, the next generation firewall has something called as session, right? Wherein it will register the C2S and S2C flow. So it will have a flow that it will understand the traffic is coming from LAN and going to WAN. And then when the reply comes, and if it matches the same parameters, right? So let me give you an example of that. Let's come down. So let's say this is your client machine. Okay, this is hitting your switch. Then this is hitting your router, and then this is hitting your internet. And let's say there is a server over here. Okay, this is your client machine. Okay, and let's say I have 192.168.1.10, and my router has a IP address of 1.1, which is having a gateway, and then it has okay, let me make it as a firewall. This is your firewall, right? So this interface will have 1.1, that will be your default gateway, and this internet will have the ISP connected, okay? And NATing, I'm not going into NAT and everything, just a simple explanation for the session part or how it works, okay? And this is your server out there, let it be 8.8.8 for sake of simplicity. All right. Now, what happens is your client initiated traffic from this machine and it tried to reach out to the server, which is hosted there on the internet, right? So, what we'll do, the traffic comes to the firewall because that will act as a default gateway. When the firewall receives this traffic, it will inspect the packet and it will see what is the source and destination. It will extract that information and then it will create a C2S flow, right? Your C2S flow will be 192.168 1.10 going towards 8.8.8.8. It might be a random port. The port that it is using for the source port will be something very random. So let's give it 65,000, for example. And this might be, let's say, port 80, destination port, right? Is 80, right? This is C2S. Now, once it receives this packet and it says this is C2S, it will automatically create an S2C flow, even though it has not received any packet, because it knows how the reply will look like, right? Because the reply will be coming from, I'm not taking the NAT part, guys. Okay, don't get confused. We'll see all this in detail. I'm just giving you for the sake of simplicity so that you understand the C2S and S2C flow. Okay. Uh, so the return traffic would be like 8.8.8.8, and the source port now will be 80, and it is going towards 192, 168, 1.10, and your destination port is going to be 65,000. Okay. Now, based on the information that is extracted from C2S, it was able to determine the S2C flow, and this information it populated on itself. Now, and this, it will call it a session, right? So this is the session. Now, first packet was your TCP SYN. It went through because there was a security policy that allowed the flow. Now, when the return traffic that would be coming back in, that would be your SYN plus ACK. It knows that this is the reply. It is not a new connection that is coming in together. It originated from 8888. The source port is 80, and the destination is this 192.168.1.10, and the destination port is 65,000. I already have a session that would be matching for this flows, right? C2S and S2C flow. So I don't need to create a separate rule for that. The same rule which allowed my C2S would be able to allow the response that will be your S2C flow, right? So my TCP SYN was allowed. Now my TCP SYN ACK is also allowed based on the same role, based on the same rule. And then your ACK will also go through by the same policy. Cool. So this is just a simplified, I mean, very simplified, guys. This is oversimplified. I don't want to make anything complicated at this point in time. I'm trying my best to simplify it so that, everyone is able to understand it and on the same page. Okay. Vignesh, hi, Amol. For IPsec, we write security policy on both directions. If stateful, IPsec should work with only one security policy. Now, we'll come to that, Vignesh. I'll explain you when that is needed and how things change over there, right? We'll tell you that. Okay. Cool. Mm. Great. So this is the reason, this is what is called a stateful or statefulness, okay? Wherein stateful means a firewall has information about the traffic flow. It is able to recognize if this is a client to server flow or a server to client flow, or this is the first packet and this is the reply of that packet, right? This information would be determined by the firewall, and then you do not need to write two separate rules for the same flow, okay? uh, and stateless, wherein it does not have any information about your, uh, the flows. You need to explicitly write those security policies to allow the traffic on both the directions, C2S as well as S2C. Okay. Yes, we do have. Obviously, I mean, everything, because everything works on TCP, or majority of the things works on TCP. Definitely, there are timers, or based on which, after, for example, your session, you sent TCP SYN and it waited for some time. If you did not get a reply, then that session would be discarded, right? But those are higher level topics. Vignesh, just hold yourself. As of now, I'll come to those things when we are discussing it, because I don't want to break the flow of what we are discussing right now. But I understand. We'll get to that part. Don't worry, and I'll make sure that everything is covered in detail. Okay, cool. So these are the differences when you talk about legacy firewalls and NGFWs. Then apart from that, there are other things. So we discussed about statefulness. We already discussed about the ACLs. Then we don't have any, no app IDs over here, right? In legacy, if you say legacy, no app IDs, no visibility, no visibility to layer 7, right? It they cannot have any understanding of it, right? It was by the you need to write two ACLs to allow same session, right? Then uh, there was no threat intelligence. Now, this is a very important part when we say threat intelligence, right? What do you mean by threat intelligence? Any one of you, would you like to answer that? Threat intelligence. Have any one of you even heard what threat intelligence is?
Essentially, is a platform where all the pages cover malicious and malware information. Okay.
Yeah. Okay.
Patterns
Uh,
of attack.
Mhm. Can you repeat that, Kishore?
I mean,
Hello.
patterns of attack.
Patterns of attack. Okay. Yeah, Deepak. Go
Yeah,
ahead.
threat definitions means the PaloAlto, which will have the some database to identify the attacks. So
Hmm.
there is some PaloAlto team behind that. They will keep on checking the new alerts, I mean new virus. If
Hmm.
they find anything, they will write the script for that. So the PanDB and PaloAlto will synchronize based on the license. So in case if any existing attack comes, it will match that particular signature and found it and uh, I mean avoid the attack. In case if it is a new one, so probably PaloAlto will compromise, but the team behind the team, right? He will keep on working on the new virus and best. Then it will they try to create new signature for that.
Great.
I
Great.
believe.
Yeah. So sort of that, yeah. I'll get some more clarity on that. But yeah, I mean, I would say you were on the right track. Yes. Uh, Anyone else, guys? Deepak, you wanted to say something? All right. Cool. No worries. Uh, so yeah, so threat intelligence is wherein, your firewall has the visibility and it's able to give you the risk pose, right? Yeah. So it can give you visibility into, first of all, the traffic that is going through. Okay. The threats that are traversing your environment, attack surface, and mitigations, right? So we have something called as, so first of all, uh, in the traditional ones, because we are just blocking the port numbers, we don't see, right, what kind of threats are actually going through your environment. Now, today, we have a lot of security profiles that we can attach, a lot of security inspection that happens on the firewall, right? Now, we have, if you will, you have capability on the firewall itself, and then again it has the capability to send the traffic to the cloud for the advanced analysis, right? We have something like this advanced threat prevention, advanced URL filtering, advanced wildfire, right? So all these things have inline cloud analysis wherein we'll send the traffic to the cloud and get, will trigger that threat and see if it is actually malicious or if there is anything suspicious about it, or we need to allow it or block it, and then we'll receive a verdict from that cloud, and then we'll be able to block it, right? Apart from that, now, we have a distributed architecture wherein we learn from your environment, we learn from another customer's environment, and we gather all the data together, and based on that we do the research, and then we'll be able to derive the signatures, the patterns, and then we understand what is the attack surface that was exploited, or what is the attack surface which the bad actors actually targeted to initiate an attack, right? So this all now, what all things, now we have something called as device telemetry, right? Wherein device telemetry will send certain data from your environment to PaloAlto networks, wherein they will be able to do research on that, right? Apart from that, you yourself will be able to review the logs, for example, threat logs, URL filtering logs, global protect logs, traffic logs. All these logs analysis will give you understanding. But again, reviewing logs is a time consuming process, right? We have something called as ACC. This ACC is really wonderful. This ACC is called as Application Command Center, right? Wherein you will be able to create customized dashboards and see what kind of traffic is actually flowing. For example, you'll be able to see each and every detail, like the network traffic. You'll be able to see the threats, and then you'll be able to categorize them as well. What threats were there? What threats were identified? What was the impact? What was the count? What was the risk score? You will be able to see everything, right? So, but again, now this might not be the very real time, but this is really good. This really gives you an insight as to how you can plan the strategies to maybe mitigate this risk in going down the line. You might be able to optimize your security policies based on this, right? Wherein, and again, apart from that, you'll be able to see what are the issues that is going on in the environment. For example, you deployed decryption, and then decryption failed for some reason. Now you don't want to go through the in-depth log analysis, taking, because that will take a lot of time. Just go to the ACC, and then you'll be able to create a dashboard and see how many failures were there with respect to decryption, and then based on that you might be able to optimize certain configurations over there, right? So this is what is we call as intelligence, wherein the firewall will give you insight, and then there are automatic mitigation deployment that could be taken. For example, if we talk about the inline cloud analysis, wherein your traffic, if anything is suspicious, would be sent to cloud, and there it would be triggered. It will give you an verdict if it is malicious, if it is a grayware, if it is phishing, if it is benign, right? And then it will send the verdict to the firewall. The firewall will be able to act upon that, right? Based on that verdict, if the traffic is malicious, just block it there, right? So these are very advanced capabilities which were not present on the legacy firewall. Cool. Uh, Kishore, you want to say anything? Because I see your hand raised, or would you like me to lower your hand? All right, cool. Thank you. Great. So I think I'd like to leave this discussion for legacy versus next generation firewall to these points only. I mean, definitely there are a lot many things that we can go and discuss, but these are the most important points that I wanted to highlight. Again, this is a theoretical stuff. It's not gonna, have anything to do with your lab sessions or anything to do with your Palo firewall. This is just a general understanding or the knowledge or information that you should have an understanding between a legacy and the next generation firewall. Okay. Kishore, we'll discuss about wildfire when we'll be discussing about the security uh, profiles, right? Wildfire is a uh, security profile that you can apply on a security rule. Generally, it's a service that is provided by Palo Alto, wherein you will be able to block zero-day attacks as well. For example, right now, some bad actor wrote a malicious program, and then it tried to attack your, they sent it through a file, okay? And that is traversing your environment. Now that file will be because it will seem suspicious to your firewall. It will send it to the Wildfire cloud. The Wildfire cloud has a sandboxing environment. It triggers it, and then it sees if it is malicious or not, and then sends the verdict back. So Wildfire is sort of a cloud, and it's a sandboxing environment where you will be able to trigger the uh, it could be a source code, it could be a file. You'll be able to trigger these and see if there is anything malicious or not, right? So effective solution for zero-day attacks. Cool. I hope we are clear with this explanation, or if you have any questions related to legacy or NGFW, I would say right now is the right time. Uh, Anything, guys? Any more questions? All right. Okay. So let's move towards our next topic for today. That is the PanOS architecture overview and licenses, right? Now, PanOS architecture, I'm pretty sure uh, all of you might have heard about. So let me let's begin from the beginning, right? What is PanOS? Right? It's an OS comes pre-built on PaloAlto firewalls, right? We call it as PanOS, that is PaloAlto Networks operating system. It will always be pre-installed on whatever devices you purchase from PaloAlto Networks. I mean, firewalls, right? Uh, Everything that you see today, let it be Prisma Access, let it be, the firewalls, everything, the architecture behind this is a Palo Alto device which will have a PanOS uh, running on it, right? So this PanOS was actually built on CentOS architecture, right? So Linux CentOS. It is built on top of Linux CentOS. Some of the commands of Linux, yes, you can run those commands, but not all of it will work because they have, uh, their own set of commands that will be executed, and based on that, backend Linux will take care of it, right? So the customization altogether is Linux or CentOS. IDS, IPS should be added extra for legacy, but PNG, yes, that's true, Vignesh. So IDS, IPS capabilities are not inbuilt on legacy firewalls. NGFW has everything inbuilt. That's why they are called NGFWs. So you're correct, yes. Cool. So PanOS has, as I was saying, Linux as the base of it. Specifically, if you'll say CentOS, sorry, is built on top of CentOS. Okay. Uh, Definitely, you will have a GUI access and CLI access for the firewalls, right? CLI, most of the time you can do, see, the mode of preference would be GUI. For configuration and troubleshooting, we generally need CLI access. This is the generalization of, operation, okay? But it is, no one is restricting you from configuring things from CLI. Yes, it has the capability. You can go ahead and run those lengthy commands and then do your configuration as well. But I believe in present day, no one would prefer to do configuration from the CLI. But yeah, there are commands that you can use and go ahead and do the configurations if you would like. Okay. So saying this, the architecture, if we talk about, the architecture that we use over here is SP3, right? This is called as single pass parallel processing architecture, right? So this is like PaloAlto firewall architecture, I would say, or it's a generalization. I'm not talking about the components of what all things are there right now, but this is a architecture that is being followed as a whole when it comes to the PaloAlto devices, wherein we say single pass parallel processing. Now, what do we mean by single pass parallel processing is, let me give you an example how it would look for any other vendors if there are in the market, right? It could be any, I would not like to name any vendor for that, but let's see, I mean, how it would look like from this perspective, right? So let me copy this. Okay, cool. Now, what you see in front of you is sort of a general implementation of other vendors. Some of the vendors I can say, I mean, I'm not saying of any particular vendor. It could be, but this is how, you know, you'll see the processing being done on most of them, right? Now, for example, if you if you'd like to enable a feature, right, how that would be processed and how that would impact your overall throughput of the device. Okay, so we'll just take a simple example. Let's say we are enabling decryption, okay, on any other vendor. This is not for Palo Alto. This is a multi-pass architecture that you can see, right? So let's say you are enabling decryption. What it will do, first it will check for firewall policy. So in order to check for firewall policy, the packet, when it arrives to the firewall, it will do layer 2, layer 3 networking, HA config, everything. It will be evaluated over here. Then it will be forwarded based on the port protocol base IDs, and then it will be forwarded to firewall policy segment or module or blade, if you'd like to call it, right? So these are called, you'll hear these terms called as blades. Now, blades are nothing but the features that you would like to enable on the firewall. Okay. Features on firewalls, generally these will be called as blades. For example, you'd like to enable antivirus or anti-spyware or uh, decryption, right? So these will be called as blades in some of the vendors. Okay. Now, decryption, as I mentioned, right, for going to firewall policy, you'll have to go through these steps. Then it will come back. Then again, we'll have to evaluate URL filtering policy. So again, the same steps. It will have to go to the HTTP decoder, and then it will go to the URL filtering policy. After this is done, it will go back. It will come here, and then again do the L2, L3, and all this processing. Then it will go to IPS decoder, IPS signature, IPS policy, right? So blade 1, blade 2, blade 3, blade 4, blade 5, blade 6, and then finally re-encrypt the traffic and send it out, right? So let's say if this was in and this was out, now imagine the time it would take for processing in this way, right? So it went to blade 1 where it was evaluated, then it was sent to blade 2 where another feature was evaluated, like URL filtering. If there is anything blocked, we have to block or allow based on the URL filtering. Then after that, it was sent to another blade, that was your IPS policy, to check if there is anything intrusion or anything malicious that is it's able to identify. Once that is done, then again it will be sent to another blade, right? That is your antivirus policy, and then again it will go back to another blade, that will be your malware analysis, right? So you can see this increases latency, okay, and causes lower throughput. Okay. So throughput is nothing, it's a measure of input and output, how much input was provided and how much output you received in what amount of time, right? So that is what we call it as throughput. Now, because we have to go through these many stages, and again, this is a time consuming way of like analyzing a traffic, this increases your latency, right? What we have on the Palo Alto is this, right? We have a single pass architecture. When I say single pass architecture, so this is sort of like, first of all, this is stream based. Okay. What do you mean by stream based? Your packets are coming in. Okay. Your packets are coming in from here. This is your in stage and this is your out stage, right? So the packets are coming in. There is no, you don't have to send them through different blades. It's simple like your train of packets coming in, going through this module, user ID, device ID. We have done whatever needed to be done over here. No further sending it to another blade. Down the line, we'll move to app ID, and then in the app ID itself, we are gonna do all the checks for everything related to application. We don't have separate blades or anything like that. All you have to do is just enable a license on the firewall and you'll have all the capabilities, right? So even app ID, it does not need any license. It will be all these checks, right? For example, SaaS security, application protocol decoding, applying the heuristics, checking the signatures, everything related to identification of app ID will be done over here. And then content ID, right? If your packet comes over here, content ID, and you'll do all the security checks, DNS security, advanced URL filtering, intrusion prevention, malware analysis, and SaaS security, DLP, everything is done in this same engine, right? So this is what we call as content inspection engine. Right? Content inspection engine. Everything is inbuilt into it. We don't have a separate blade. Okay, after doing SaaS security, send it to malware analysis. After malware analysis, send it to intrusion prevention. No, we don't have that. Right? A packet will go into a content inspection engine. Everything, the pattern will be run in one go, and they'll be able to extract all the information in just one pass. Right? And then it will, based on these output, if it is to be allowed or denied, will be checked by the policy engine, right? So we have certain engines. We do not have separate blades or separate system wherein we have to run through, we have to push all this data or the packets through these stages, and then, it might take a lot of time. So this is your single pass architecture wherein this highly improves the throughput, and this makes your uh, uh, you know the latency minimum, right? You'll have the least latency because we are not taking too much of time. We do not have different steps that it has to go through. It will be able to do everything in a stream based pattern and in just one go, right? So this is your single pass. And then when we talk about parallel processing, so this is in software. Okay. And when we talk about parallel processing, this is in your hardware. Okay. So how do we do that parallel processing? We have a multi DP architecture, right? Wherein multi DP architecture. Okay. What do you mean by that? We mean by that is, don't worry, guys. I mean, we'll discuss about data plane, management plane, the segmentation, the segregation, how that management operation is separated from the data plane and all that. There's just a overview understanding. So don't worry too much about it. Okay. So multi-DP architecture means wherein your traffic is coming in. This is our data plane. Okay. And we will have like DP0, DP1, DP2, which will be able to process your traffic parallelly. Okay. So this is taking care of one flow. This might be able to take care of other flow, and this might be able to take care of other flows, right? So everything is done parallelly, and then it is sent sequentially through the wire, right? So the traffic will come in, will be processed parallelly, and then it will leave out. Okay. This is what we'll call as parallel processing, right? So this is where it comes SP3, single pass parallel processing, wherein you have multi DP architecture where DP is nothing but data plane, wherein there are multiple CPUs that will be doing their job of inspection, or doing everything, right, allowing or denying traffic based on the threat security profiles and other profiles, right? So whatever processing needs to be done on a packet will be done by your DP CPUs, right? So we'll talk about this, how DP CPUs actually work, how your data plane segmentation and everything, the traffic will never go to the management plane and all that. But just for the sake of simplicity, right now there are multiple CPUs that will take care of processing of the traffic parallelly and then sending out the traffic, right? So this again highly enhances the performance because of parallel processing. This is performance optimized, right? So and then again we have dedicated chipsets. For example, there is a chip that will take care of networking only, so it is hard coded. It does not have to vary. I mean, your packets will not be sent to multiple locations for inspection, and then they will not be evaluated on multiple CPUs for route lookup maybe. Okay, we have a dedicated network chip that will take care of the routing policies and everything, what needs to be done for that packet. I mean, from which interface this was received on and to what interface it has to leave, everything will be taken care by a single chip that will be a networking chip. Similarly, data plane CPUs will take care of the processing of the traffic parallelly, right? So this is why we call it as a performance optimized uh, single pass parallel processing architecture. Cool. Any questions on these? Okay. What is the role of management plane? Okay. So management plane is simple, right? The name itself says it takes care of all the management responsibilities. For example, if you whatever GUI that you get the access of, right? For example, you like to go ahead and configure the uh, firewall, right? And then you'll enter the IP address of that firewall on your browser and then access the GUI. How that will work? That is the management plane is going to take care of that, right? So we'll have certain daemons that runs on management plane, and then these operations, whatever is needed, will be taken care by your management plane. Cool. We'll get into detail further, but I guess this is good enough explanation for now. I hope that helps you to clarify it. Anyone else, guys? Okay, cool. So we covered legacy versus NGFW. We covered the PANOS architecture overview. We need to discuss about the licenses now, right? So I have already taken out the list of the licenses that is available that you can apply. Why do you need to update app ID once in 2 to 3 weeks? Because every day, I mean, there is a new application coming in the market, and then again, PaloAlto will have to update their definitions of those applications, right? Or for example, you were using Skype. Now you don't see anywhere Skype, right? Now that might have been updated to maybe new app, or some other company might have purchased it. Now their application signature will change. So that is why we need to update your uh, app and thread database, right? Uh, Ignish, I mean, I understand what you're saying. Packet flows and everything, wherein life of a packet and life of a session. I do have a plan to include that. Definitely, I'll do that. But as of now, I mean, see, I'm trying to keep it simple because there might be a lot of guys who are fairly new to firewalls, right? I'm just trying to not to overwhelm them so that they get scared in the beginning itself, right? But definitely I'll touch base on these topics as well, even though they might not have been listed over there, but I'll touch base on these. Okay, cool. So let's talk about the subscriptions that you can use with the firewall, right? So these are the licenses that you can purchase from Palo Alto Networks and then apply on your license. So you it's not as simple as that you purchase the firewall and then you're good. No, that's not how it works. So you can buy a firewall. It will have some basic capabilities, but to enable security, IPS, IDS, you need licenses. Okay, there are no separate modules that you are going to install on that firewall. The firewall has everything inbuilt into it, but the licenses will enable that feature. Okay, so IoT security. So we all know what is IoT. IoT is Internet of Things, wherein everything is getting connected. There will be like Zigbee. There will be different small equipments. It might be headless. It might not have a GUI or something like that, but it is providing some sort of access or some sort of like utility, maybe to end user or maybe to a corporate environment. Now this is where we call it as Internet of Things, right? These are small things. Even if you see, your AC nowadays has a Wi-Fi. It has like remote capabilities. You can turn on your Wi-Fi while you're driving back home, so it is connected to the internet. So these things are getting evolved right now. Now how do you control this? So we have something called as IoT security. I just gave you an AC example in normal home household environment, but in corporate environment there are other implementations of IoT. If you see, like in the hospital, in the healthcare departments, right? In the healthcare industry, you will see there are small devices that are connected, and for example, monitoring the patient, right? The patient monitoring system is very crucial nowadays because it will monitor all the uh, parameters of the patient, and then if there is anything not right, it will send a alert to the doctor or maybe to the relatives, right? So these things again needs to be protected because these are vulnerable to attacks. So this is where IoT security comes into the picture. We have a list of devices that will be supported and everything. I'm not going to discuss what all things are supported as of now, but I'm just discussing the subscriptions or the licenses that you can apply to the firewalls. Okay. So IoT security is one of them. To secure your IoT environment, if you have any, you'll be able to discover the devices. You'll be able to protect the devices using the IoT security. Okay. We have SD-WAN license. Now this SD-WAN is PANOS SD-WAN. This is not Prisma SD-WAN. There are two flavors of SD-WANs that we have with PaloAlto networks. One is Prisma SD-WAN, the other one is the PANOS SD-WAN. So this SD-WAN license that I'm talking about is a PANOS SD-WAN license that could be applied on the firewall so that you will be able to deploy these firewalls as a branch and a hub, or a full mesh topology, whatever you prefer. And then based on that, there will be IPsec tunnels that will be automatically provisioned, and the traffic will be secure, right? So SD-WAN, yeah. Apart from that, we have threat prevention, and then you will see something called as advanced threat prevention. Now, these threat prevention are like sort of like uh, going away now. These are legacy licenses that used to that were there. Now, after some time, these will be gone. As of now, still, I guess they are still here, but they are going to go away pretty soon. So we call them legacy licenses. Now we have newer version of them. We call them as advanced threat prevention. Now you'll say, what is so different about threat prevention and advanced threat prevention? So threat prevention, well, as the name says, right, it will have all the signatures, database for threats, vulnerabilities and everything. Advanced threat prevention, the one I talked about, is in cloud, inline cloud analysis, if you remember. So that functionality would be enabled based on this advanced threat prevention, wherein all the traffic would be sent to a cloud environment to investigate it further. That will help you even with the zero-day attacks, and kind of like making it more robust security. Okay, so that is the difference between legacy and wherever you see advanced. So in advanced, we are using machine learning. We are sending the traffic to cloud environment wherein they will be investigated further. Okay, we have DNS security. DNS security is, again, as the name suggests, it is to secure the DNS, do the inspection on the DNS queries, and see if it is heading towards malicious, or if it is carrying anything malicious, and subject it to inspection, right? We have again URL filtering over here is a legacy license, and then we have advanced URL filtering. Advanced URL filtering will have inline cloud analysis and machine learning, patterns and machine learning deployed, so that you will be able to detect or make the URL filtering more effective, right? Wherein we would be able to block the traffic based on the categories, and then at the same time we'll be able to determine if anything is malicious or not. Okay. So this is legacy. This is the new licenses that are there, advanced URL filtering. Same goes with the wildfire and advanced wildfire. Uh, Advanced wildfire, the same thing. We have a sandboxing environment that is there in the cloud. Now, see, you will say, okay, Amol, you say advanced threat prevention has a cloud environment, advanced URL filtering has a cloud environment, and then you say advanced wildfire. Are they sending it to the same cloud? No. Advanced wildfire has a separate sandboxing environment wherein certain types of files will be sent, right? It could be a PDF, it could be JPG. There, so all these the file types that are supported might be different from this, and from this. Okay, so that is where the difference is. All right. So advanced wildfire, wherein there will be the supported file types will be sent, which whichever deemed whichever are suspicious will be sent to the cloud environment, and then they will be triggered, and then there will be a verdict that will be passed on to the firewall. At the same time, we the moment if we find anything malicious, the definitions will be created right then there itself, and then those definitions will be deployed globally so that everyone else will also be protected using the same signatures. Okay. Cortex Data Lake, this is a logging functionality wherein this will enable a logging service, and you will be able to select that for log forwarding. This is hosted on cloud, wherein all your logs you will be able to retrieve it from the CDL. This comes into sort of like 1 TB licenses, right? If you'd like more, then you'll have to buy like 5 licenses, will give you 5 TB of storage, okay, on cloud. Then Global Protect Gateway, this is where your GP comes into the picture. Uh, Most of the functionalities for a simple lab you can do without license. You don't need a license. But if you'd like to host a portal on a different firewall and then gateway on a different firewall, for those you need licenses. If you have Android phones that you'd like to secure, or if you have Linux machines, then you'll need licenses, right? If you're doing a third party authentication, right, where third party, you're using an XAuth for authenticating your users, then you'll need this license, right? We have then virtual systems, wherein virtual system is like those who might have worked on Cisco's, they might be aware that a firewall can be divided into multiple contexts. Similarly, Palo Alto says that we can divide it into multiple virtual systems or VCs, right? So we call this as multi VCs. Multi VCs, right? So, for example, if I buy a data center box or a chassis box like 7K, right? So what I can do, I can apply a multi VCs license on that 7K firewall, and then I can segment that firewall into 2 or 3 firewalls or 5 firewalls based on the multi VCs license that apply. So what will happen? There will be we that box might be one box physically, but then I will be able to use it as a separate firewall. Okay, so I'll have this VCs 1, VCs 2, VCs 3. This will have a separate security rules. This will have a separate security rules, and this will have separate security rule sets, right? So this is what is called as virtual systems. This is only applicable to the physical boxes. Just keep that in mind. Uh, a VM is already virtual. You cannot have a multi VCs or a virtual system inside a virtual box. So whatever VMs that we are spinning on our lab, we do not have that capability at all, because this is a feature specific to physical or hardware based firewalls. Okay. Then comes your enterprise data loss prevention, or DLP. Now, data loss prevention is becoming more and more, sort of like a requirement for nowadays, right? Given you might be able to see there are a lot of data breaches. Somewhere trying, the bad actors were able to exfiltrate some of the information, and they got the sensitive information that was there stored on some cloud storage or some of the internal environment, right? So, and this could be because of some of the users, they were sorry, some of the users by mistake shared their credentials to a malicious website. They might not be aware that the website is malicious, but unfortunately they shared their credentials, and then the data got leaked, right? So we have a solution called as DLP, wherein that DLP will be able to scan your sensitive information. You will be able to scan if you're providing credentials to a not trusted website, right? It will be able to scan assets that are there on your cloud, right? So if you have, for example, a box application that is there, it's a SaaS application, you are hosting your files over there, then your DLP will be able to scan all these files and see what sort of sensitive information is stored over there, and if anything is shared with an external user or not, right? So I know this gets a lot complicated and sophisticated, but we'll eventually see smaller bits. DLP is actually not a part in PC NSE, but I'll give you a general idea how things work. Same goes for SaaS security inline. Uh, this is again cloud functionality wherein uh, we now have called as ACE, right? That is your application cloud app ID cloud engine, wherein uh, PanOS in itself has close to 4K application signatures. And then we leverage ACE, which is there in the cloud, which is your app ID cloud engine, has close to 68,000 application ID signatures, right? So this highly increases the capability. And then we are talking specifically about the SaaS applications, okay? So whatever applications you have on your desktop that might not be a SaaS, or whatever application, we need to understand that the SaaS applications are the applications which are delivered or you'll be able to access over the internet, and then they have some sort of like upload or download, or maybe editing functionalities over there on the cloud itself, right, or on the internet itself. So those applications are called as SaaS applications, right? So this again, you can apply to your firewall and then secure your SaaS applications as well. Okay, this leverages the ACE, that is your application cloud engine, and then enhances the capabilities of the uh, firewall, I would say, right, to secure all these applications. Great. So these are the licenses that you will be able to use with the firewall. Any question on these, guys? All right, cool. So I'll take that as a no, and let's head forward. So that covers this and Panos architecture overview and licenses. Let's talk about the form factor, physical VM, CN series, and cloud and GFW. Okay. Uh, okay, here's some message. Panorama is also licensed. Yes, Vignesh, Panorama, we need a license wherein it will be able to manage a certain number of firewalls. So we have like 25 devices that could be managed. So you'll have a license for that. Then again, there are like 1,000 uh, devices license, and so on, right? So yes, Panorama also needs license in order for it to function, right? So for discussing the form factors, I'll take you to the internet, to the PaloAlto's website. Uh, we have this website, which is really wonderful, I would say, right? So here we call it as a product selection, wherein you can come and review what kind of product that you would like to select, and based on that you'll also be able to get the details of that particular product, right? So now we have a lot of series, right? So let me give you some of the common ones. So you will be able to see, I'm talking about physical as of now, right? So the physical firewalls will come into like PA 220s, 820, 850, right? So these are smaller boxes. Then we have 440, 450, right? These are smaller boxes. Then we have somewhat bigger boxes, just higher than these, right? PA 1400 series firewalls, like 1410, 1420, right? 1460. So that will be PA 1400s. Then we have PA 3200s. We have PA 5200s. Then we have PA 5400s. Then we have PA 7K series, right? So the 7K series is a very heavy box, is a chassis box, which generally is deployed in the data centers, right? So these are the series that we have for 1400s, 3200s, 5200s, and 5400s, and then 7Ks, right? So 220s, 820, 850, 440, 450. These are smaller boxes or very simple boxes that could be deployed in a small environment. And then as your requirement increases, you can go down the line, right? So let's see what all capabilities they have, right? Why they are different from each other. So if you see 5410, right, you'll be able to see the throughput is 52 gigs, right? If you see 5420, you see the throughput is 70 gigs, right? The threat prevention throughput is 35 gig for 5410, and then threat prevention throughput for 5420 is 50 gigs, right? And then you'll be able to see a very important part, the performance, right? Connections per second. It can handle 270,000 connections per second, and the maximum sessions that is supported is, I guess, 50 lakhs, right? If you come here for 5420, you can see the maximum sessions supported is 70 lakhs, and the maximum connections per second that it could handle is 3,70,000. So this is the site where you can go ahead and review individual models, right? So we talked about 5400s. So we have 5410, 5420, 5430, 5440. This is new, 5445. I have never seen anything like this. This, I assume this might be fairly new. But you can see the capacity increased a lot, right? 90 gigs app ID firewall throughput, and then max connections is 48, 4 crore 80 lakhs, I believe, right? That is for IPv. The most important thing. This is the max sessions, right? So yeah, this is a very huge box that could be deployed. Now, based on the requirement, so it's always based on the end user requirement, how many users they have, what kind of session, what kind of traffic will be there, right?
Oh,
So what kind of traffic will be there? Based on that, you'll be able to select a box and then deploy it in your environment, right? So we do have 3410s, 3420, 3430. And then these are the 7K boxes that I talked about. So 7K, 7080 is the top model in 7K. You'll be able to see the throughput is huge, right? 590 gigs per second with app ID, right? Even though you are running that app ID engine, along with that, you will get 590 gigs per second of throughput, right? If you enable all the threat prevention capabilities, that is what it is called as threat prevention throughput. And you can see 305 gigs per second. And the connections per second is like, it's huge, right? Similarly, if you see the max sessions, it's way beyond, right? So this is where your uh, physical firewalls you can come and check. And then again, I was talking about VSys, right? Let me go ahead and see. Yeah, virtual systems. This has a base virtual systems of 25, right? And then if you need more virtual systems than 25, you can have at the max of 225. But this would need license. So base virtual systems do not need license. These are the virtual systems that you can configure by default. That is why it is called as base virtual systems. But if you need more than that, then you will have max virtual systems that you can have on this firewall will be 225. That is huge, right? So but again, that needs a lot of planning. You cannot just go ahead and deploy 225 contexts on a firewall. Okay. So this is about the physical form factors. You can, I'll share this in the chat box. Please feel free to navigate through this website. Try to explore. You'll get more information on that. Okay. Let me see. We should have VM series as well over here. So that was about physical PAVM models. Now, these are the VM series models that we have currently, right? VM50, VM100, VM200, VM300, VM1000 HV, 500, 700. The most common ones that you will see will be VM300, 500, 700 in the environment. And for the smaller ones, you will be able to see VM100, right? You will be able right now, what you can see on your screen is the number of sessions that is being supported. VM50 is a very small VM for very small environments, just can support is 50,000 sessions at a time. And you can see there is a limitation on the security rules as well, right? So 250 security rules, 200 in light mode if you're running this VM in a light mode. And then dynamic IP addresses, security zones, it can just have 15 security zones, right? And then there is a limitation for IPsec VPN tunnels of 250. And then SSL VPN tunnels of 250. So these are the, again, I'll share this in the chat box. These are the VM series models that we have. Uh, no difference when it comes to the functionality part, wherein you will be able to do the inspection and everything over here. And it will, the only difference that you might say is the physical firewalls have dedicated hardware, wherein this would be like virtualized software, and then it will have the things running on the software part of it, right? So yeah, these were about the VM series model. Let's talk about CN series model. Now, what is CN series, right? So now the firewalls that I just showed you, VM series, are the exact one firewalls that you'll be able to deploy in a container, right? But what container and what will be supported, what will be not supported, will depend on the PAN-OS versions that we'll try to deploy. We'll talk about these versions in detail, like what is the current PAN-OS version, what is the preferred release, and what PAN-OS ideally we should have on our environment, what we have in our lab environment. We'll see all that, right? But as of now, when I talk about these CN series supported environments, CN series is nothing but a container series firewall. Now you will be able to deploy those VM50, VM100, VM200, 300, 700, 500, right? In a container or a Docker container environment. For that, there are certain prerequisites that should be there are certain requirements that should be met in order for you to able to deploy those firewalls, right? Now you can see all these requirements over here. Anyways, we are not going to cover CN series in our course, but you can definitely go through it, what our supported environments are. You can see if you would like to deploy a PAN-OS 10.1, then Docker, CRIO, and containers, you can go ahead and deploy in all of these. For 10.2 and till 11.2, I think the requirement is same, but the Kubernetes version that would be needed, again, that is also same. 1.7 through 1.27, and then cloud provider managed Kubernetes. If you're deploying it on so you might deploy a Kubernetes engine on a cloud that could be AWS, Azure, or anywhere, and then on that Kubernetes you'll be able to run your CN series firewalls. Okay. So again, let me go ahead and share this document. CN series, there's nothing different. Again, the only difference is instead of running your firewalls on a cloud and on a virtual platform, right, like a VMware or something, you are running that in a cloud Docker environment, right, or a container environment. Okay, so that is what is called a CN series. Let me share that article as well. Cool. This was done. Now, apart from CN series, what are the versions were there? Cloud NGFW, right? What is Cloud NGFW? This is nothing but a cloud native solution. Okay. No infrastructure to manage, a few clicks is all it takes, right? So wherein you don't have to deploy the VMware or any virtualization software or any such thing. No, you don't need to worry about it. All you have to do is go on AWS and then just, click, 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 your firewall is deployed. That's it. You don't have to manage that platform or the hardware for that particular firewall, the virtualization software. No, nothing. You just manage the firewall. That's it. So this is what is called as cloud NGFW, which is a cloud native solution, right? Where so you can see we have this over AWS, wherein you can go ahead and deploy it directly. Now, why this would be preferred? Okay, this would be preferred because it takes least amount of time, right? For example, you have your environment and you want to go ahead and deploy network security. You want a firewall in place. Go ahead and deploy cloud NGFW, provided your traffic, you'll be able to route the traffic towards the cloud. Okay, that is one of the requirements for this, because the traffic, this cloud NGFW is present on AWS, wherein you will be able to route your traffic through the cloud and then send it to its destination. Okay, so if that is the requirement, and then you want the firewall to be deployed in the least amount of time, you can just go ahead and deploy cloud and JFW, few clicks, and your firewall is deployed. That's it, right? You don't have to manage the hardware. You don't have to manage the virtualization software. Nothing. You will just take care of your firewall. That's it, and then you'll be able to do the inspection and the security services. So that's the reason cloud and JFW will be preferred, as we see every other company is moving to cloud. Uh, Going down the line, they would definitely need a security solution which is native to the cloud, right? So again, the firewall, the PAN OS, the security capabilities is gonna be the same. There might be few one of the features, there might be something different that might look a bit different, but these will be minor changes. There won't be any functionality change with respect to the firewall. Okay, so if you'd like, you can go through the cloud NGFW. You can review this. Cool. All right. So that's what I intended to cover today. So yeah, form factors, we have covered this as well, right? So let me stop recording and I'll give you sorry. Where is that stop recording? Okay.